Yeah. Good evening, friends. Before starting this session, do you have any idea on embedded system? I think you heard about the videos. Maybe first video. All of you heard about the first video, am I right? So based on that video, can anyone tell me what is the definition of embedded system?
It's the combination of hardware and software, which is intended for do one process only.
Okay, good. Can I call microcontroller? Can I call as a computer?
Yes, sir.
Okay. Generally, basic question. What computer contains? One CPU, means you say microprocessor. What are the peripherals? Basic peripherals. If you want to run one computer, what are the basic peripherals you require?
Keyboard.
Input. Keyboard means input. Monitor output. CPU, microprocessor. Memory. RAM. Basically, these are sufficient. Is all these things are not available in the microcontroller? All these things are available in my. So can I call microcontroller as a single chip computer? Yeah. So here I want to discuss a little bit brief overview, like some deep points, wherever small critical fundamental points is where we are missing. I'll cover that points. Okay. So here generally my talk start with computing systems. Generally computing systems means what are they? Desktop, like our PCs, workstations, laptops. These are called desktop machines. Servers. Okay. If you see servers, network appliance, web server, application and database server. Okay. Do you find any real-time problem? Suppose while you are accessing your Yahoo Mail or Gmail, sometimes it is giving message server down. What it means? Do you know how our Yahoo Mail or Gmail, all these things are working?
Data is stored in some data center.
Where?
Some server.
So server means what is that?
Mail server.
Means how your main server is there?
It contains database of all the accounts.
It's server also a PC. Don't think the server is different, but the designing of the server is like that. It is only maximum storing the data. Okay, their architecture is a little bit different. It having like in desktop PCs, what is the maximum memory, maximum hard disk we have? 1 TB currently, or 2 TB. If we say server, it having 100 TB. 100 TB of information and some database software, database link up. Okay, that is connected to your external board. Suppose if you are creating on Gmail, okay, just you are logging the gmail.com, just you are typing that thing. Do you know how it is routing? Gmail having one IP address. Okay, it is converted into IP address, sending to the request to the server. Okay, so once if it is giving the acknowledgement as well as some coding part, HTML code. The HTML code loaded in your browser, you are getting the first window. So suppose if you want to enter your username and password, if you sign in, so the information sent to the web server, and from the server to it is connected to your database. From your database it is searching for your ID and next it is checking for your password. If both are valid, whatever the content available in that server, it is loaded in your PC. So backend this much processing is there. So basically servers are you understood, it's also normal PCs, but it having high-end configuration, especially memory point of view, and high-end database architecture is there. It's not look like a general desktops. Third one is embedded systems. See why I call all these three systems are computing systems, because all are similar. Where the variation is coming, I will explain you. So if you see embedded system examples, PDA, personal data assistant. Another one is cell phones, routers. Do you know where routers are used?
Connecting different types of networks.
Yes, LAN, wireless, If you want to connect some of the let us take example of your college. In your college, some of the systems are LAN connected systems, some of systems are Wi-Fi connected systems. Their routers are playing key role connecting between LAN and wireless LAN. Okay. Yes. See, this is the go for next slide. Yeah. See, this is the basic difference between your general purpose computer and embedded system. Okay. If you see your general purpose computer, we have some applications. Generally, if you consider your general purpose computer, it requires one operating system. Am I right? What OS is doing, it will interface the hardware to your application. It acts as a medium. Okay. Whereas Windows, we can't see any kernel, all kind of things. But if you go for Linux, you can understand what is exactly operating system. But Windows, all are hidden process. Every operating system, whatever the operating system concepts you are studying in your theoretical part, everything is in Windows is there, but it's a hidden process. It's abstraction. That whatever the content is there, abstraction. Only you are seeing the file names. That's it. But whereas Linux, you can really see the things, how your kernel process is going on. You can access the kernel also. Okay. And whereas typical embedded systems, we need not require any OS. Okay. Generally OS, what is the applications of OS?
It can access the interface and it schedules the process.
Schedule the process. If suppose if you are loading 10 applications, it will schedule, because we have only one CPU in our PC. Our CPU is not multitasking thing. Okay. Simultaneously one by one. Okay. But whereas nowadays you see, you heard about Core to Duo processors. Core to Duo, we have two virtual processors. It seems to be single processor, but internally two virtual processors is there. Something you are working, one processor is working. Something background work you are doing something. Suppose background operation. Suppose you are converting some file, one format to another format, one video file, AVI format to DVXA format. So it's conversion. So another virtual processor take care about that. It's a parallel. Okay. So scheduling the task, scheduling the algorithms. Okay, link up with our hardware to applications. Okay, if you want to connect to your internet, you require one Ethernet. But if you open browser, if you click something, directly Ethernet is connected. No, your operating system is create a virtual path to your hardware. From your browser to browser means HTTP browser. From your HTTP application to your hardware. I think you studied about OSL layer. 7-layer architecture. There you can clearly understand where the operating system plays vital role. But this is embedded systems, it doesn't require any hardware. Simple software is there. Okay, and some application. Like, see, this is general purpose versus. Go for next slide. General purpose versus special computers. So, based on that, can you give me any difference? Do you find any difference for general operating systems and embedded systems?
General operating system, we can develop any applications. I mean, many applications we can develop from the general purpose version, but this specific purpose we are using embedded system.
Why we can't able to implement our applications in our embedded system?
We are not designing any platform. We are designing any RTOS connectors so that we can develop
what is the memory of, assume that RAM memory of your general purpose computer? 1 GB, 2 GB. Whereas your microcontrollers, if you consider hard disk, what is the size of your hard disk? What is the size of your flash memory in microcontrollers? Okay. What is the processor speed in our computers? 2 GHz, 3 GHz. What is the cache memory? 3 MB. Whereas coming to microcontrollers, up to 16-bit you can't find any cache, but 32-bit microcontroller architecture, like ARM microcontroller architecture, you can find the cache memory. But here processor speed how much in your microcontrollers? 10 MHz, 60 MHz, 100 MHz, 400 MHz. Even not gigahertz also. Megahertz only. Even your iPhone, It's a 400 MHz processor. So these are the basic differences. See, in general purpose computer, lot of memory, lot of features, all these things are available, and we are loading one operating system, we are implementing anything. Nowadays, your computer, you can connect any of the electronic device. Nowadays, like, earlier it's not like that. Nowadays, the reason is embedding. All these things are embedding. And next, one more thing is in these things, what are the general embed special purpose things? Memory one parameter, speed one parameter, peripherals one parameter. So the limitation is there. So based on the limitation, we can implement as a special applications. We are not implement as a PC, but we can implement as a special applications. Let us take one example: microwave oven. Just what is the microwave oven operation? Heating something, some temperature, some threshold temperature, whatever they are setting the temperature. Once you are power on that thing, it directly goes to the temperature? Gradually. Why gradually increasing? Are you understand my point? Suppose if you are, now the temperature, suppose the temperature is it's very cold. So if you want to increase 35 degrees, now current temperature is 20 degrees. If you click 35 degrees temperature, if it suddenly goes to 35, what happened? What damage?
Because sudden increase the component may melt and heat.
Okay. But whatever you are, anytime do you study the data sheets? Do you have a habitude to study the data sheets? See, if you want to see the data sheet, if you see the temperature rangings, minus 40 degrees to 85 degrees, maximum any component having this feature. But I am giving 35 degrees only. Lifetime of the product will be decreasing. The device may not damage, but the lifetime is decreasing, and also the food, whatever the food we want to heat, it may gone back, or some chemical reactions may happen. So some gradual increasing. That is called feedback. Whatever you are seeing, your nowadays micro ovens, do you think it's a simple thing? But it's not simple thing. The micro ovens, embedded systems, they are using PID algorithms. Feedback system. So gradually, step by step, step by step means they have to take the output temperature and current input temperature they are measuring. They are calculating the error. Do you study about control systems? Feedback systems. Here same. Here they are applying PID, proportional derivative integrative algorithms. They are increasing the temperature gradually. That's what nowadays you can see the microwave oven. Okay. So there we need not really require a high speed processor, 2 GHz processor. I don't want a for 1 GB RAM. I don't want 500 GB hard disk. I don't want these serial ports or so and so, so and so. What I require simply, one temperature sensor, one relay, one microcontroller, one indicator, some monitoring, and some push button interfaces. These things only required. So based on my requirements, I can choose a simple microcontroller. That is also a computer system, single chip computer. But have limited features, but that limited features is sufficient for making another product. Got my point? So this is the basic difference between general purpose as well as special purpose. Whereas if you compare with practical only, you can understand what is the really basic difference between these things. Okay? See, even airplanes also, he is considering as embedded systems. But not complete airplane is a not embedded system. Some of the PCs is there, but most of the things are embedded. But those are real-time embedded systems, hard real-time embedded systems you can say, because even one fraction of second also may crashes the airplane. Okay. If you see, these are the different market fields. So where it is high? Industrial, it's approximately 20%. Out of 100% market, industrial automation and process control is 20% in our embedded market. Second thing is this transport, like communication equipment, like networks. Networking means your LANs, routers, DSNL modems. All these things are embedded systems. Okay. Whereas you can see like yeah, communication equipment, terminal. Like if you see your mobile phone towers, those are also embedded systems. BST, base station, master station, all these things. If you see, anytime if you visit there, there are a lot of microcontrollers is there, lot of sensors is there, lot of relays is there. Okay, because it's having analog and as well as digital combination. Okay, like another thing is office equipment, like our peripherals, like printers, fax, modems. All these things are office based. Like if personal information appliances, like our mobiles, PDAs, all these things are entertainment and education, like small PCs for children using like ARM9 processors for kids. Recently heard about some Wipro, I don't know, some company is releasing 4,000 rupees laptop for kids, PlayStation kind of things. And audio visual equipment, you can see nowadays you can find USB based sound cards, PCI based sound cards. Out of motherboard you can find PCI based sound cards, small USB based sound cards. All these things are embedded systems. They are small DSP processor with USB interface, and there some driver programming is there. If it is there, if you install the driver, it will communicate with using a USB protocol, and we can hear the thing, music. Like home appliances, home security, home automation in home appliances, and like regular things, refrigerator, washing machine, heater, water heaters, like ovens, micro ovens, all these things are there. Like miscellaneous, some medical equipment, especially biomedical equipment. If you see biomedical equipment means ECG recorders, EEG recorders, temperature monitoring systems, like operation theaters, you can find different type of equipments. The costly and sophisticated equipment, the systems, it contains number of processors, number of 32-bit ARM processors. It may not contain single processor. Whether if you see the complex systems, if I previously explained about the microwave example, there you require one processor. But if you want to implement a complex system, you may require number of processors. Like electrical equipment, like nowadays is fuse breakers, automatic fuse breakers, like triac, diac based automation systems, automatic remote based power on and off, all these things, electrical based. So like that, embedded system is like this, like different fields it is there. Next, definition of the embedded system. Tell me the definition of embedded system. Yeah, Govind, please. Definition of embedded system, according to your point of view.
Embedded system, it is a combination of both hardware and software. It can do for specific tasks.
Okay. Okay. Can you give some example?
Yes, sir. Example means our mobile phones.
Okay. Can you explain the mobile phone, how it acts as embedded system? According to your definition.
In my definition, in mobile, it has inside the hardware, sir. Whenever మనం ఎప్పుడైతే మాట్లాడుతున్నప్పుడు అది డేటాని ట్రాన్స్మిట్ అవుతుంది. ట్రాన్స్మిట్ అయిన తర్వాత ఇంకో రిసీవ్ పార్ట్ రిసీవ్ చేసుకుని ఏదైతే డేటా అనేది రిసీవ్ అవుతుందో అది రిసీవ్ చేసుకున్న ఎగ్జాక్ట్ డేటాని మనకి అవుట్పుట్ చేస్తుంది. లోపల ఏమవుతుందంటే మన డేటా మాత్రం తీసుకొని మిగతా నాయకులని రిమూవ్ చేసేసి ఉంటుంది.
One basic question for all of you. Do you think in our mobile phones only one processor is there or several processors?
Depending upon if for high-end mobile we have two processors. One is for DSP for audio video and another is for other.
Most of our mobiles based on ARM architecture. I'll discuss later. This is okay. See, the task and application both are different. If you see, once you how to explain this definition, you should take care depending on your example. If you say only one task, nowadays most of the embedded systems are not single task. Task means only simple work, small work. But all our embedded systems are multitasking. You see, not several tasks. It may contain several tasks. If you see our mobile phone will not only receiving the calls, listening the music or gaming or several applications is there, SMS, MMS. So these are different tasks. Okay. So here I am explaining some general examples about these things. No, I am not saying multitasking at a time. Sequential execution only, but switching is there. Task switching is there. Suppose if you are playing some game in your mobile, if you receive one call, what happened? Did you receive the call or you won't receive the call? Because in our mobiles, receiving call is the highest priority. It generates one interrupt. It generates high priority interrupt. So first of all, what are the operations happening in your mobile? First you have to receive the call. It's the highest priority. Okay, their priorities is there. That we will discuss one by one. Okay, here I am giving some different definitions. See, all of definitions may contain, but only one thing is this embedded system is a simple computer having some software and hardware to perform specific application. Okay, let me see. I have some software. I have some hardware, 2-3 microcontroller, 2-3 sensors, 2-4 actuators is there. I am connecting. Some application I downloaded. Is it work? Some software. It may not relevant to whatever the existing thing. It may not relevant to whatever I required. Some software. It won't work. So just whatever you are connecting the electrical device, it doesn't have any brain. Whatever you are writing a software or firmware, generally it is called firmware in embedded systems. Okay, that having the intelligence, that is creating the intelligence for these devices. Okay, like small example, if you purchase one new PC, if you don't load operating system, what happened if your PC is working? Even though if you purchase high-end PC, nothing. So you have to load the OS. If you want to load the OS, you have to, suppose you have like your processor supports up to XP only, but if you loaded Windows 2000, won't support, or your processor only support up to XP. If you want to try to load Windows 7, that's what. So you have to write a software according to our application. Generally, in this definition, there is a small clarification. Embedded system is a combination of software and hardware to perform specific application. So hardware also precise. Like if you want to, if you don't connect the processor, if you want to try to download the operating system, or if you don't connect RAM, try to load the operating system. No. So it's a combination of hardware and specific hardware and software to compatible software and hardware, you can say, to perform specific application. Where we can elaborate the embedded system definition. And nowadays, embedded system is, it's only not only single microcontroller. Most of the embedded systems are having 2, 3, 4 processors. But all these processors are connected to one bus, some bus architecture, like different protocols, like parallel architecture, or you can say serial architecture. All these are transmitting the data. Okay. Generally, in our mobile phones, minimum 2 to 4 processors is there, depending on our mobile complexity. Because whatever we are using, some data processing, audio processing is very important parameter. Do you think whatever we are doing audio processing, we have to, whatever our voice is analog signal, but how it is transmitting, it have to convert the ADPCM, pulse coded modulator, have to convert into pulse coded modulator, then it is connected to the same pulse coded modulator, it is connected to your GSM modem or GPS receiver, it is there in your mobile. It is transmit the data to that one, and it will convert the like it will add with 845 MHz or 1800 MHz. It's a carrier frequencies of your mobiles. Like if you see in your mobiles, it supports 845 to 855 MHz or 1800 to 1900 MHz. If you see your mobile specifications, those are the uplink and downlink frequencies. Okay. Because why I am telling downlink means whatever your base stations, you have to transmit high frequencies. Whatever we are transmitting, some down frequency 945 MHz. The frequency is increasing. So power consumption, all these things are coming to factor. So based on that, your frequency spectrums are there. So it have to do all this process, and as well as while you have to receive the data, it will decode the data, it will convert into analog format, all this processing. So imagine it's how it's real time, how it is real time. If I am speaking there, it will there. It's a full duplex communication. Assume that how much faster our processors. Okay. Yeah. So based on that, we can classify the embedded systems of 3 types. Like small scale embedded systems, generally these are 8-bit or 16-bit microcontrollers, and having very little bit software complexity, hardware complexity, and most probably C language is used for the programming this kind of things. Okay. Another thing is medium scale embedded systems, whereas our mobiles coming under category of medium scale. It may have using 16 or 32-bit DSP or RISC processors, DSP or ARM processors or OMAP processors, and some software hardware complexity. In this middle scale systems also, it may contain 2-3 processors. It may not be single processor, it may contain 2-3 processors depending on the application. Some other peripheral ICs also it may connected. All these things. Okay. And its little bit software hardware complexity may increase. It's not simple C, it's a high level C as well as huge code. Like you can say 10,000 lines of coding, 20,000 lines of coding. Okay. Next, sophisticated embedded systems. These are especially coming under the real-time applications, whereas industrial real-time automation, nuclear power plants, radar controllers, flight controlling, MIG controlling, all these are sophisticated embedded systems. Once you have to design one system using in this category, the system won't fail in any worst case. Like that, they are designing the things. That's what. While designing this type of sophisticated system, it takes long time for testing only. Implementing it may easy, but testing and checking the long durability, all these things, it takes much time compared to designing. Suppose if you are designing this system, this type of system within 3 months, testing it may take 2 years also. Because the reason is straightforward. If you are testing with 4 or 5 months, okay, if you approved means, suppose something is failure in real time, the damage is you can't even expect. Assume that one nuclear power plant should may blast. What happened? You can't even imagine the result. So that's what. While designing this sophisticated system, they may use number of processors. We can say 10, 20, 15, depending on the requirements. Okay. Yeah. Why do we need embedded systems? First of all, what is the first reason why we require embedded systems?
Cost of
Okay. Okay. Yes, reducing our human intervention. The first reason of embedded systems why they are inventing is reducing a human intervention. Because human intervention, some mistakes may happen. So whereas sophisticated kind of things, it's not predictable. One is predictability, fault tolerant. So if you compare to man and machine thing, man may do many mistakes, but machine maximum won't do mistakes. And if it's a safety point of view also. So compare it on man and machine, whatever you are writing a program, it will work according to our program. But man, whatever, if you keep one man to operate some machine, depending on his mood, he may work. So these are several parameters we require for embedded, where people are interested to working on embedded systems. Nowadays, 10 years back, imagine 10 years back, you can't find mobile phones very hardly. You can find mobile phones very hardly, I think so. Like mobile phone cost itself, you say 30,000, 40,000. If you want to make a small, that's too not all features. And having only black and white, simple display mobile, 30,000, 40,000. If you want to make a call, 3 rupees, 4 rupees charges. Nowadays, see the revolution, competition, revolution, exploring the technology. Past 50 years, 30 years, how embedded systems are growing. 30 years back, how embedded systems are there. Now you can see the embedded systems. After 20 years, you can't even imagine the type of embedded systems you are finding, like automated cars, Simply you just click automate button. The car will go automatically based on whatever you have to give the source path and destination path. It will take care. It will give the path. It will go for according to traffic conditions, everything automated. So there the key roles of technologies are Wi-Fi, Zigbee, GPRS. All this playing key role. Why Bluetooth may not play key role is power. Power and distance. See, okay, distance okay, but the power is the main criteria. If you just power on your Bluetooth in your mobile device, check the power level. Within 1 hour, your mobile battery is discharged. Whether you are using Bluetooth or not doesn't matter. But once you are power on your Bluetooth, it's continuously searching for the devices. So it's continuous searching means it have to transmit some power, transmit some signals. So automatically our power is reduced. That's what best mobile solution is. If you want to require long duration of battery, you don't power on the Bluetooth and don't power on any of the peripheral you don't want. Nowadays you can find your most of the advanced mobiles, most of the recent mobiles having automatic sleep down mode. Suppose if you are not using mobile within 1 second, it's automatically goes into sleep mode. Camera also, if you just click, if you don't use 30 seconds or 40 seconds, it is went in sleep mode. If you are not using music player, means if you just after completion of song you won't off the music player, automatically it will wait for some time, automatically it will sleep mode. So all these things are reducing the power consumption, increasing the life of battery. Okay, that's what satellites, especially robotics, the power consumption is a very, very critical parameter. We will discuss one by one point. Yeah. So these are some examples of embedded systems. So features of embedded systems. So in market nowadays you can find wide variety of chips. Like the basic competitor is Atmel, TA, Microchip. These are the basic competitors for industrial automation. Most of the embedded products. Now recently ST also added. But only ST is very famous for your memories and nothing, but it is not very famous for microcontrollers. It having microcontroller thing. One more thing is Renesas microcontrollers. But most competitor is Microchip as well as TA. And Atmel also very high competitor. So many companies, and even you can find like Atmel also you can find ARM9 or ARM7, ARM7 TDMI architecture, ARM99 architecture. Like you can find TA also you can find ARM7 TDMI architecture, ARM9 architecture. Like Microchip also you can find ARM architecture. Like Renesas also you can find ARM architecture. Okay, as well as you can find the ARM architecture in several companies, ARM Cortex, several companies are offering ARM4 architecture or different types of microcontrollers. So what happened? Due to this competition, your price will be reducing. Your microcontroller price or your whatever peripheral price is decreasing. So you are getting a cheaper product. So nowadays you can imagine we are getting the mobile phone of 1500 rupees. Do you think if you purchase a simple GSM modem outside, it's costing 2400. But a mobile phone with all basic features like camera, like keyboard, music player, touch screen, all these things, China mobile you can find within 1500 rupees. What is the difference? Why simple like GSM modem if you want to purchase it is 2000 rupees, 2400 rupees. If you want to purchase a product 1400 rupees. Yeah, mass production is one of the parameter and quality. So why that's what China mobile says. If it is working, it's working fine. If it is not working, throw it in dustbin. There is no warranty because whatever they are making very cheap products. It may without proper testing also. Simply assembling the things and checking once. Okay, over. Suppose it is gone, fell down once. We don't know what happened to that mobile. If your time is good, it will work. Otherwise, throw it in dustbin. Because there is no repair centers. Now you can find China mobiles. Because if you see China mobile, if you open the China mobile, see the complexity is like this. Hardware you can't able to replace that things. Okay. Second thing, language and high level tools. Nowadays, like you can write earlier you only came to know C language, but Python scripting, some scripting language, using scripting language also we can implement embedded coding. After all, compiler, whatever you are writing a code, high level code, it should be converted into assembly language, from assembly language to instructions. That's what a compiler should do. So there is Python based compiler, Basecamp code case compilers, Pascal based compilers. Different compilers are available nowadays, and Java based compilers, Eclipse. Because nowadays software people are also interested to working on this embedded domain, like implement a software for the system. They need not really require the hardware architecture. Just you have to explain what is the input you want, what is the inputs you want, what are the outputs. So they will design a software. So some persons are very good expert in Java, some other persons are Python, some others are parallel scripting. So people are thinking, why don't we create a compiler so it can convert that language into our mission language. So people are nowadays working on that architectures only. Maybe within 10 years you may not find C, embedded system means embedded C, not only embedded C, we can find many of the languages. Okay. Next, many of the IO series component selections. Like nowadays if we see microcontrollers, once they are releasing some microcontroller in market, they are explaining they are highlighting the additional features. They are not highlighting what are the existing features. What are the additional features are available, they are highlighting in your mobiles also. See, suppose Nokia releasing one version of mobile, okay, another version of mobile it is releasing. So in another version having some advantage with same price. So what they are highlighting? What are the advantages there? They are highlighting that things only. So here also, so the peripherals, like peripheral count is increasing every time. Okay, like a program on direct port operations. Like microprocessor, we may not program directly on ports. If you use microprocessor 8086, you have to connect a PPA, programmable peripheral interface 8255. From 8255 to you have to interface your ports. But whereas microcontrollers directly you can read the port operations. Okay, programming with multitasking and multi-threading executions. Suppose if you are porting some ATAs, so there is multitasking, multi-threading, different operations you can perform, where really require the real-time operations. Like most of them use cross-compiler development tools. What is this cross-compiler development tools?
Doing compiling the application in one platform and making input equal and governance of target code.
Cross-compiler.
Converting the high-level to assembly.
Okay. So shall we discuss with something? You have familiar with basic C? All are you working turbo C? Okay. In our PCs, how many bit processor is there? In our PCs we have PCs, right? Intel P4 core to dual core processors we have. How many bit processors are there?
32 bits. I mean 32.
Core to dual 32 bit processor only. Where you having two parallel things. Anyway, a 32 bit processor is there. So your instruction size is 30 bit. If you consider our normal 805 microcontroller, how many bit that is? 8 bit. Suppose if I am implementing a code, C code on turbo using turbo Z, I am generating hex file, I am generating exe file. Is it possible to port that exe file in 8051? Why?
That processor only.
Okay. Is it possible or not? First question. No. Then why? See, if you understand this concept, I am sure cross compiler you are very clear. Okay. See, you are using some Intel architecture. Intel having some register set, it having some register set, register banks and different things. But if you consider 8051, it having its own register, and instruction size is 8 bit. This instruction size is 32-bit. So how it will execute the 32-bit instructions in 8-bit microcontroller? It's not possible. Am I right? So what people are implementing? They are implementing a cross compiler. Whatever we are called turbo C, all these things are native compilers. Whatever C, B, C++, all these things are native compilers. It will generate the instructions or it will generate the code according to your x86 architecture. Generally our 32-bit architectures are called x86 architecture and 64-bit architectures are called x64 architectures. Okay. Generally if you go for Linux or if you go for high-end terminology, then you can, people don't call as a processor, they call x86 architecture. Okay. If you see x86 architecture, it will generate the if you compile any code, it will generate the instructions or it will generate the machine code according to your architecture. Whereas cross compiler, it will work on same x86 architecture, but it will convert the instructions according to your target system, means target microcontroller. It is executing in a 32-bit architecture only, but the output instructions according to your target. So if you assume that keel is a cross compiler, so if you write a C code, same C code if you write in normal turbo C also it will work, but header files may vary because stdio is related to your PC. But if you use keel compiler 8051 means include ridge51.h or 8051.h, just you are including, instead of stdio you are including 8051. If you are including stdio.h, whatever the registers are there in PC according to the architecture it will generate. If you include 8051.h, whatever the registers and SFRs, all this content are available, it will load. So it will generate according to your header file architecture, final hex file. So you can pour that hex file, you can run the operation. That is called cross compiler. It will work on some platform. It will generate the output file according to our target system. That is called cross compiler. Clear all of you? Yeah. Like emulator. What is the difference between simulator and emulator? So generally we are debugging tools, means we are studying about the software simulator, hardware simulator, emulator. Did you find any difference between all are same, do you think? Tell me what is the difference?
Same like this cross compiler like this.
Yeah, software simulator means suppose in your 8051 you can simulate the thing, but your 8051 wherever you were loaded in x86 architecture, but it will create a virtual environment of 8051 architecture. So where you can simulate your instructions step by step while you are debugging your keys 8051 programming. It will create a virtual environment of 8051 architecture, because our output file is according to 8051 architecture, but in whatever the currently we are having x86 architecture. So your simulator, software simulator, create a virtual environment, not real environment, virtual environment, and load that instruction and show the results according to that. Okay, this is called software simulator. Hardware simulator means directly you can connect your hardware from software, from PC to you can control step by step. It's called software simulator. Emulator. And the emulator, it's also doing simulation, but it's not doing the same system. Suppose I want to do emulation, especially if you consider a piece of microcontrollers. If I want to debug some code, whatever we are using chips, if I am directly download the code, I can't able to emulate. There are separate ICs. Suppose we are using some XXX architecture, some ABCD architecture, some ABCD version of architecture, microcontroller we are using. If you want to emulate, if you say emulator is there, we are not downloading the code in ABCD, we are not debugging the thing. Some other device, some ABCDEF, it supports the ABCD architecture, we have to download our hex file into ABCDEF architecture, we have to emulate, we have to simulate the things. Means simple terms, we are not downloading, we are not debugging the code in actual hardware. Some other hardware, it is similar to your actual hardware, We are debugging our things in the hardware. Got it? Or once again I can repeat. Emulation means we are not doing the simulation in the same target system, same target microcontroller. There are separate microcontrollers is there which will support the same architecture. Whatever we want to simulate the microcontroller, same architecture is there. It supports that architecture. So we have to download our X file into this microcontroller. We have to debug the things. Suppose any errors is there, we have to rectify. Once again, everything is fine. So final X file you can download in your actual microcontroller. That is called emulator. There is a difference between simulator and emulator. Remember these things. Clear, all of you? Like debugging on a normal PC. Things is there. Like where especially you have like high-end architectures, okay, where you are not able to read the flash memory properly, or some segmentation things is there, we are going to use emulator. Especially PSOC we are using emulator. There is no JTAG debugger or simulators. Only emulator is there. But PIC we have emulator also is there, simulators also is there. But the cost of emulators and simulators are cost very high. Whereas in simple normal JTAG debuggers you can find. But especially if you want to work for real simulator or emulator, the cost is very high. Even one simple emulator it may cost 2 lakhs also. 2 lakhs, 3 lakhs. Where the people really working on real time projects, where the time is very precision, there they are using emulators or simulators, depending on the requirements. Okay? Like all these things is there. See. Once again this slide is like different embedded systems I am showing there. Like whatever the nowadays like PlayStations, those are also embedded systems. Okay, digital cams, all these things. So here next slide I am giving the short list of embedded systems. So like where exactly we are using in embedded systems. Okay, just go through once. Just different applications. Like coming to market of embedded systems. Previously I am just showing in percentages something, but here little bit clarity I want to give a little bit clarity. Like automotive. Generally nowadays if you see the bikes, modern bikes, earlier bikes it having speedometer, analog speedometer. Nowadays digital speedometer and also self start and different features. Like different features are there in they are embedded in bikes or automobiles. Signal indicators, everything. Most of the things they are embedding. Like if you see nowadays cars, earlier days if you want to back the car, you have to check whether many people is there. Nowadays in view mirror you can find the image of thing. So back they are keeping one camera, so they are seeing the visions directly. Like something is if you want to nearby wall, it will give some buzzer indication kind of thing. Several things they are embedding. Okay. Whereas nowadays disc brakes in mobile bikes, if you see high-end bikes like 1 lakh, 2 lakhs bikes, they call the term called disc brakes. There is also an embedded system. Means if you directly pressing that thing, there is also PID algorithms, fuzzy logic controllers. Those are. So if you click that button, it doesn't directly stop that things. So based on the input, it have to read the current speed, and based on the input, very slowly means some process it should be applied, like some logic it should be applied, and it should slow down the. Suppose if you suddenly it is stopping, what happened? If you are going for 80, if you click that disc brake, what happened? Those things. That's what. So many fields, especially we can't even imagine. Whatever we are studying in our embedded systems, all these things are in our real-time mode, real world only. Besides of us only. Whatever we are using, real-time bikes, all these things. That's what disc brakes. If you see normal bike and disc brake bike, the cost is variation is very high. You can say 30,000 difference, 20,000 difference also is there. Because of the implementing of this complex algorithm. Because that should be real time. Once you are pressing back means within fraction of millisecond or millisecond only the fuzzy logic control algorithm is applying, and the bike speed should be decreasing. Am I right? Once you are clicking back after 2 seconds it is reducing means what is the use? So there is high-end complex algorithms, high-end processors, high-end ASIC processors. There they may use not normal ARM9 this kind of thing. They are using special purpose microcontrollers especially dedicated for this type of operations. Are you understood the things? So what is a microcontroller? It's a combination of ASIC chip. Whatever the things are you want, all the things are connected, and you have some VHDL code if you implement, if you make a bit file, if you fab it, it's a microcontroller. So those are general purpose microcontroller. Whereas this kind of brake systems, all these things, they need not require all the things. What are the necessary things are there? Necessary things are required like computations, if you require fuzzy logic controlling, all these things are there. Only they are embedding, they are making that type of chips only. That's what the cost is very high. Nowadays, means recent, most probably within last few 4-5 years only, these disc brakes, all these things are there. So once time is going on, the costs are reduced. Because once the competitors are entered, means your cost is automatically reduced. Initially, it relies only the mobile phone network, relies only the thing. So its cost for 3 rupees, 4 rupees. One call if you make it. Even if you are receiving incoming call also, they are charging. Earlier days. Nowadays, you can't even imagine. Every 3 seconds, 3 paisa per 1 minute, 5 paisa per 1 minute. Different things is there, different offers because of the competition. If you see medicals, like infusion pumps, where infusion pump means you can see in emergency wards or ICUs, you can find like oxygen marks. Like you can monitor based on the respiration levels. You can monitor things. If you see ICU equipment, those are like dialysis machines. Like if you want to nowadays, you can see our lab medical lab. If you went for doctor, so he prefer some tests, some dialysis tests. Okay, blood test, some different tests. So why those things are very cheaper right now currently compared to earlier days? Why those things are cheaper means all those things are portable, as well as some processing algorithms they are applying. They are making special purpose devices for this testing purpose. That's what. Nowadays you can find, if you want to check your blood level, sugar level in your blood, you have to go to doctor, you have to give your blood, you have to. Nowadays you can see in market 10,000 rupees, if you afford means you can find a blood level. It's a simple embedded system, a little bit complex embedded system. So now people need not wait for the sugar level testing, temperature monitoring, BP monitoring. Nowadays portable biomedical equipments you can find in medical shops. It's a revolution of embedded systems. So there is networking like routers, hubs, gateways, like where these gateways are using. See, generally in our India, BSNL is the ISP, Internet Service Provider. Throughout India, BSNL is the service provider. He will sell some IPs for this Airtel, who are providing the internet, like Tata Indicom, Reliance. The BSNL is selling all these things. So there are some ISPs. So they are giving to some local persons. Like if you see a local 24/7, if you can find local. So they are also distributing the things like this network. So where the gateways are using. Suppose if you purchase one IP, from that IP to you have to develop your network. So you have to take that IP from BSNL. You have to connect this gateway. From this gateway to what are the things you want, you can connect. Like office automation, see fax machines, copiers, printers, scanners, card readers, monitors. See, nowadays you can find a card reader of cost of 25 rupees. You can't even imagine. Recently I purchased one card reader. Earlier I purchased one card reader at 2 years back. Its cost is 200 rupees. If I open that card reader, I find one ARM chip, okay, ARM microcontroller, and one USB which supports USB protocol. Other side is MMC card reader. He is connecting all the things are parallelly. Protocol, MMC card reader, ARM supports MMC card reading, MMC protocol, simply connecting. Recently I purchased one card reader. Its cost is he is selling 40 rupees, but if you purchase a bulk, he told that he will give by 25 rupees. If I open that thing, I can't find any microcontroller, only one CUB chip, carbon chip. If you open your calculators or video games, you can find a black chip. If you open the black chip, means a small cob, a small circuit is there. Like that in memory card reader, I can find the chip and one USB connector, a few resistors, connectors. That's it. If you purchase company with 300, 500, you can find a microcontroller fine. Okay? But here, imagine how embedded systems are reducing the cost. like robotics. You know how robotics are play vital role in different experiments in industries, or like space vehicles, Mars, Beagle Mars something, one robot. So based on the robot, they are identify some basic information about Mars. So like if you see control systems, satellites, missiles, nuclear reactors, space stations, shuttles, space shuttles. See, all these things are mixture of embedded systems. Okay, like consumer electronics. Nowadays, your consumer electronics best example is your digital box, digital TV receiver. What after all he is giving? He is giving a dish. He is connecting one SIM card. For your subscription ID identification, how he is managing all the things? He is connecting one SIM card. So based on how much you recharge, the channels he is allowing. Simply, one microcontroller, one processor or controller is there controlling your input signals. You are receiving all the channels. Whatever he is sending, all the channels you are receiving from your antenna to your box. But what are the channels it is allowing based on the recharges and all these things? Based on the message information, it will release that frequencies only. Then how he can manage that things? How different people want different channels. How he can manage using same hardware? Are you understand my point? Hardware is same. He won't change the hardware. He can't provide a different hardware for different people. Hardware is same. Just he is only controlling the things. Based on the recharges, based on your number, he is allowing that frequencies only. So you can watch particular channels only. Okay. Like here once again I am just why I am giving this much information means just it's a repetitive thing. So once we are clear about these things, then we can understand what exactly really we can learn in embedded systems. Got it? Otherwise embedded system means I can say 3-4 lines over. Definition is over. Why I am explaining all this stuff means if you understand the basic stuff where really embedded systems are there, so you can work more. That's what my main intention. Like see, in some application. And also, now onwards, suppose if you want to explain embedded systems to some other people, some other students coming here, you should be able in a position to explain this PPT. I am not saying just you may not be explained 100%. At least the person who you are explaining to you, whom you are explaining, the person after completion of your class, at least he can get an idea of what is embedded system, where exactly these applications are there. There is a basic intention of this PPT. Okay. Assume that whatever the students we are expecting from BTech level, they don't have any basic knowledge of even microprocessor also, I can say. Even if you ask me about the flip-flops or NAND gate, NOR gate operations also, they have some doubts. So keep in mind, assume that the person is layman, please explain the proper way, like based on his inputs or based on their inputs, so you can explain the things. Okay. Like these are some examples. I'm just skipping these examples. Now you can see commercial applications like you can see these systems, this type of systems. Like if you see like if you see APS RTC, mostly using this kind of things, automatic ticketing, single bus drivers. So he is only giving the ticket. What he is doing after all? Just you have to enter the inputs. And also power bill. Earlier days, how our power bill generation is there? There some person is coming, they are recording the things on paper. Later he entered into something and he generated the power bill. Nowadays, just enter within fraction of minutes. That's the advantage. That's the things are happening. So all these things are processors, different microcontrollers, processors, simple interfaces, and implementing a proper software. That's it. But getting a proper application. Hotels. If you want earlier, they are printing some tokens, different tokens in. Nowadays, simply whatever you want, you just tell the order, just enter the number, getting the tokens. And like parking systems. Parking systems also. Earlier you have to give some token. We have to search for token. Nowadays, ticket. So just a simple Then this slide I am just explaining the top level block diagram of embedded system. You can see it's embedded computer. It having some software and hardware, some input variable, output variable, linking to some other system. Like if you want to maintain a database, it's linking the thing, and some user interface. That's a top level block diagram. There you can't find any microcontroller or any microprocessor. What are the peripherals is there? Simple some hardware, software, input, output, connection, user interface. The next slide. Here the data flow. We can see some elaborated picture of previous block diagram. We can see like some hardware means like you say like some processing or controlling unit, and some of the inputs like from sensor inputs. You can see sensor input may be analog or digital, it may be whatever it may be. It have to process, depending on the output you have to control some actuator. So based on the input data you have to perform the processing, because our microcontrollers or processors can only understand the digital data format. It won't understand the analog format. So you have to receive the data, convert analog format to digital. From digital data you have to apply the things. What is it? Based on the digital data, find out what are the input level. So based on that you have to apply some algorithms. So based on that you have to control the output. Like it's typical. Next diagram. See, it's something elaborated picture of in previous slide. So you can say one CPU. The CPU may be microcontroller or ASIC or FPGA. So I can tell already ASIC means some dedicated chip, where I discussing with brake control systems, some dedicated chips based on our operations, like analog to digital conversion, sensors, CPUs. So your human interface means it may be anything like keyboards or switches or anything. Like diagnostic tools means debuggers, emulator, simulator kind of thing. Okay, like it's a feedback control system, like it's a typical embedded system. All these things controlled by software, where the software is loaded in memory. That's what if you see the block diagram, he is not given the software anywhere, just he is linked up with memory. So whatever we are implementing a software, we are storing in memory. What type of memory we are loading? Volatile memory or non-volatile memory? Non-volatile memory means tell me. It stores permanently. Means where? How many types of memories? Yeah, we will discuss the things. Okay. This is some other block diagram where you can find different sensor interfaces, like input output. If you see microphone, tachometer, all these sensors, sonar sensor or position sensor, switch, these are inputs, like wireless connection, LCD, computer, some embedded system. If you want to interface another embedded system also, so there is two systems are there. Okay, you can connect some using some protocol. This is another block diagram. It's a real time. Next slide. Yeah. Here is some real time example I am giving. Like if you in India may not be this type of system may not be available. Like if somewhere you ONGC gas pipes is there. Okay. Suppose some gas is there. So what is the gas level? Means how much force gas is coming? Very less or no? So there is a pressure sensor is there. Here some pressure sensor is there. Based on the pressure of the gas, it will sense and convert into analog to digital processing, and it will open the valve. Maybe these kind of things you can find in the ONGC, these kind of where the natural gas resources stations, natural gas plants, all these things you can find the things. It should be real time, because if based on the pressure, if you not control the valve properly, the pipe may be blasted. Nowadays you can see most of the last 1 or 2 months some 3-4 gas pipes are blast due to only these small reasons, small leakages, and they are not accurately calculating the pressures, they are not checking the things properly. So once this type of things are blasted means it's difficult to control the things. Like aerospace, especially 2 days back, practical example, GSLV. The reason is people are saying it's a simple reason. because of one cryogenic engine, some water is there. They are not fix up the problem properly. Just there. So how many crores? It's a 360 crores. And how much time effort? 4 to 5 years effort. How many people manpower? So only one simple. It may be a little bit complex, but compared to all these efforts, it's a simple result. Even if they are postpone their experiment another 1 week also, no one. No. But they are not doing like that. But simply they are just. People are saying negligence, or whatever it may be reasons. That's what. If you want to make a design, these are parameters. You have to take care all the parameters, all the aspects. Do you know in embedded systems, at least one people is sufficient to implement a code and implement a thing. But do you know why MNCs all these things? Even that is a small work. Why they are giving group of people? Views. The person views. Suppose if you are seeing the system in one point of view, other person may see another point of view. Some other person may view another point of view. If group of people point of view, it will give a good solution. That's what in software also, hardware also, like any software field or embedded system field. Even the project required only one intelligent person is sufficient to do all the process. Maximum 80% of the thing he will done. But why people are giving this much? They are recruiting this many people and they are allocating these works. Do you know? So the reason is missing. Testing. Why they are keeping testing for more people for software, monitoring, making for documentation. Different people is there. Because of the reason is this one. Like embedded networking, routers, gateways. See this block. Next slide. If you go for next slide, see it's almost 7:40. I'll continue another 5 minutes. I'll break it today. So tomorrow once again we'll discuss. Okay. So here see the block diagram of microcontroller. What is there? One processor, one RAM-ROM, input interface. Like if you want to press set the temperature, you require input key, and a door open. No, if you door open means your temperature should be automatically temperature element should be automatically shut down. So you have to find out the door open kind of thing also. Whether door is closed or open, you have to measure. And it's like a magnetron. This is a heating coil. Fan. Like if you want to, because temperature should not increase gradually. Some process. So they are increasing as well as there some controlling mechanism also is there. Like perfect control system. Feedback based control system. As well as light. If you open the door, the light should automatically glow. Display, temperature display. It's a typical microwave. Where one thing is missing, like temperature sensor. That's the main thing. Okay. It's a block diagram of digital camera. Whatever we are seeing, digital camera. So optical lens. You have to find. Suppose if you are adjusting the zoom, some zoom display is there. So how they are finding the zoom display? So optical sensors, they are getting some analog voltage. From analog to digital conversion, they are connecting system controller and image storage. It's SD card and LCD screen. So it takes the data and shows in your LCD. In digital camera, whatever we are seeing your images in LCD, like computer interface. Nowadays, you can connect your cameras to PC using USB. Flash out. So whenever you are clicking, then only your flash should work. Timer and motor, like maybe if you see high-end cameras, maybe normal digital cameras it may not require. If you see high-end cameras where in our college functions they are using big lens and reel based cameras, their motor control also one more parameter. High-end digital cameras having reel also. Okay. Next. These are the designing issues. Earlier I told you. So first one is cost. So if you want to design a system, if you want to design a good system, but the system cost is 10,000, other person is a little bit compared to your system, a little less features is there, but system cost is 3,000. Generally people, what they prefer? 3,000 only, because features little bit less. People that can adjust there because of cost factor, because price, whatever he is offering, our cost is price. So cost is very important parameter. Nowadays you can see why our Nokia mobile is dead on. 4 years back, 5 years back, you can say Nokia is a top in India. Now why? Why Nokia is not in top? China mobiles or other brands, like you can find number of brands. Even one brand of mobiles, they can release n number of models because of price. Cost is a major parameter. Am I right? Like I/O capability. So if you want to take a microcontroller, how many I/Os it having? So these I/Os are sufficient for our design. Suppose I required 40 I/Os. If I go for a 32-bit I/O microcontroller, no, I have to go for more than 40 I/Os. So high-end processors. If you see normal 40-pin ICs, it having maximum 32-pin I/Os. But if I want to 36 means, I have to go for 48-pin IC or 64-pin IC. So I/O compatibility. Capability, not compatibility. Capability, I/O capability. Also count size. If you are designing a good system, but the system size is this much, another person making a small system, comparison also is there. Like nowadays you can see like China mobiles, this much size or bigger mobiles are there earlier. Nowadays all these features are made in small. People are purchasing smaller one only, because they may not keep that much bigger mobiles in their pockets, or they have to handle with care. Power consumption, yeah, you are keeping high-end features, boss, but your battery backup is half an hour. Are you trying to purchase that mobile? That's what. See, these are the parameters. Maybe this seems to be very silly things, but in real-time design, these are the main key challenging roles. Do you know where the power consumption? If you want to implement a logic, where if you use for loop, it will take more instructions, or if you use while loop, it will use more instructions. That level also, instead of one variable, if they want increment, what type of increment they want to use, post increment or pre increment or simple for loop increment kind of thing. All these code optimizations they will do, because if the less instruction execution means power consumption will reduce. So while high-end designing, power consumption is related to your software optimization. You don't even imagine your for loop. If you see your for loop executes 6 instruction cycles, whereas if you go to condition, it's consume 4 instruction cycles only. Suppose that will rotate 1 lakh times. If you want to perform some operation, it will rotate 1 lakh times. How many cycles I can say? 2 lakhs times. Imagine 2 lakhs times if I saving means I can get at least another 15 minutes battery. So these are the real-time considerations. Means here I am just giving the word, but each word having its own background. It's not simple things. Like on-chip memory, it's a very important parameter. Suppose if I am taking one microcontroller having 4K flash, but my code is 6K flash. Well, whatever I am building the software 6K. What I have to do? Am I have to interface external memory? No. So I have to select the high-end memory. So 32K flash memory or 8K flash memory. So that thing also important. Suppose let us assume you are selecting a good microcontroller, it is set for all these things, it having 64K, but your application is 65K. The people won't change the microcontroller. Once again, they are optimizing their code. If it is nearby round up things, they can try to optimize the code, so they are nearly 64K. Like all these things are happening. Performance. So performance is very important parameter. Suppose if your mobile or if your whatever electronic device, it is working long time means you will happy. You suggest some people, suggest other people to purchase this brand, but it is not working properly in your. Or you suggest. That's what the criteria. Do you know why nowadays our mobiles we are getting n number of models? Earlier starting level R&D level. R&D level means everything they are interfacing, their things they are getting this message. So later they are making special chips for this, especially mobile making kind of things. So once they are designing, they will select blocks, IP codes, intellectual property. Like GSM interface is there for your mobile. They are just selling a block of code for different types of microcontrollers. It will suit for five number of microcontrollers. So whatever want to mobile manufacturer, what he can do, just he is simply purchasing that mobile controller, that piece of code and controller, and so he is purchasing some other LCD interface, purchasing some other person, some intellectual property. He is integrating all these things. He is making a mobile. That's it. That's what your mobile production is nowadays. You are getting n number of models. Suppose if you want to add the camera, earlier days camera interfacing R&D. Once the R&D is over, simply plug in, code plug in. The person who are selling the intellectual property, he is not selling the actual source code. Binary files he is giving. So you can't debug the things, what is there inside, how he is writing. Like if you have basic idea of a C++, inheritance concept, abstraction, encapsulation terms. So his encapsulation, all his code, he is just giving the binaries. Suppose in C language also, if I am implementing the C code, just I am compiling, I am giving only exe file. Just you can give the inputs, it will give the output. Do you know really what logic I used in that my C program? No. Just you can use input output. Like that also, mobile phone. Now, that's what our mobile phones are. We are getting n number of models only due to that intellectual property. Purchasing, integrating, selling. That's it. So his effort, his cost, his effort is reducing, because if you purchase once intellectual property, he can use for 1 lakh or 10 lakh mobiles also. But the person who is really doing the R&D, his cost may be nothing. He is efforting so much cost. That's what in embedded systems, prototype designing is very critical task. People are underestimating the prototype designing. Nowadays I can find so many people are prototyping, prototype orders, we want to product, but they don't know all this really. They don't know really who are really doing the MTech project or BTech project or some other projects. They don't know really thing. Why IITs or some foreign universities, US, UK, each and everything the students should do. They have to submit their reports. Their viva also very tough, and also submitting the reports that some format is there. Don't copy from internet. You have to write your own. There are some softwares is there. Suppose if you give your document, it will find how much percentage you are using for internet coding. All these things here. That's what they are quality. Our education system is like this. It's a fact. Like software. And what software you are using? If you are using assembly, generally we have general assembly and C. Which is better? As of your personal feeling.
Embedded is user friendly, sir. But
According to performance point of view, as ASM is the best one, because if you write in C language, one third party compiler convert it into assembly language. Suppose if you directly write it, it may take 3 instructions, but the compiler converts 20 instructions. Got it my point? So really, if you work on high-end programming codes, you can find these things. Like inline assembly codes is there. If you write inline assembly with C codes, you can compare the things. Surely you can understand. Where really your debuggers or simulators are handful for that debugging kind of things. You can understand the things. Okay? Like software also very important thing. And instruction set. Like how many instructions you are using. It's a very important parameter. Because if your instructions are increasing, like your CPU CPU execution cycle is increasing. Like your instruction cycle is increasing. Like one instruction may require 2-3 cycles, whereas other microcontroller required only single instruction cycle. Based on that, like development tools. The development tools are corporate or free tools. If you want to implement a MATLAB cost is 50 lakhs. Any small scale company is afford that thing? For their project cost itself 50 lakhs. Is they able to invest 50 lakhs software? So software tools also. It seems to be low cost, user friendly, all these parameters. Testability and reliability. These are the very, very important. Testing is a very, very important in embedded systems. Reliability, long life duration. These are the critical facts. Okay. Now I'm stopping here, and next slide may be designing considerations. Whatever I'm talking about, the cost, all these things. Another chart, like characteristics, we will discuss tomorrow. Okay. Thank you. Any doubts so far? Any doubts?
What is the maximum number of sensors we can interface with microcontroller?
That is depending on your microcontroller. Number of pins and microcontroller, and what type of sensors you want to interface. So, if you want to interface analog to digital converter, whether the microcontroller having analog to digital converters, how many analog to digital converters is there? Let us take PIC microcontroller and having 8 analog. Am I right? 8 channel ADC is there. It means one ADC is there, but it is multiplexing with 8 channels. So at a time you can connect 8 analog sensors, but you can't connect. If you want to connect me, you have to external interface. Like external ADCs are there, which is talking with SPI protocol to your microcontroller, like MCP3208. It's a 8 channel ADC. You can connect 8 in the analog inputs. It will convert the analog to digital format. It is sending through microcontroller. It is sending the data to your microcontroller using SPI protocol, SPI protocol. Like depending on your application, you have to select the microcontroller. Suppose the inputs are high, so you have to connect some external things. So if there is 100 analog inputs is there, if you want to use same PIC, so you have to connect number of these ADC and protocols. They are there, but the performance is reducing. Got it, my point? The performance time will be reducing. Suppose if you directly using direct ADC, it may take around 15 microsecond or 25 microsecond for one ADC conversion and getting the value. But whereas if you use this SPI based things, means it may take 1 millisecond, 2 millisecond, 3 millisecond, where your time is increasing. So whether that time slot is sufficient for your operations or not, you have to cross check. If it is not, you have to go for high speed ADCs and high speed processor. Okay. Any doubts? Okay. So most probably day after tomorrow you have a test on this embedded system PPT. Okay. It's objective type and descriptive type also. So day after tomorrow you have a test. Tomorrow I'll explain the things. Day after tomorrow, most probably Thursday or Friday, I'll conduct a test on this embedded system. Fine.